Alright, so this map of 6 square blocks, it shows the location of May's house on the bottom left with the M, her grandfather's house, G, and the library labeled L. So it's asking how many different routes can May take to walk from her house to the library to get a book, and then to her grandfather's house for lunch, assuming she does not walk more than a total of 7 blocks. Now, first let's just look at our restriction. What does that really mean? She can't walk for more than a total of 7 blocks. Well, think about this. If she's going from her house, M, to the library, L, it's going to be 4 different blocks minimum because she has to go right twice and up twice as well. It doesn't matter what order she does it in. She could go like this, that would be 4, or she could go like this, that would be 4. I mean, that's just minimum. She could theoretically loop around a bunch like that, but we're just looking at minimums because there's a restriction of 7 total blocks. So there's a minimum 4 block, right? 4 steps, I guess. So there's a minimum of 4 blocks taken to go from M to L. Now, what about from L to G? Well, she has to go right once and then down twice, and that's 3 blocks. So, I mean, really what this question is saying is because it's a minimum of 4 blocks to go from May's house to her grandfather to the library, and then it's a minimum of 3 blocks to go from the library to her grandfather's house. Basically, what this question is saying is how many ways can May go from her house to the library, only going up and right, and then go from her library to her grandfather's house, only going right and down, because that's just how you get the minimum number of blocks traveled. So anyways, how many ways are there for May to go from her house to the library, right? Well, she has to go, like I said, right twice and up twice. It doesn't matter the order that she does it in, as long as she only goes in those directions. So basically what we're saying is how many ways can you rearrange, 2 rights and 2 ups. That's going to be the number of different routes May can take. So we're going to use the choose function for this, as we have in many problems in the past. And so there's 4 different objects here, n equals 4. Now there's 2 that repeat here and 2 that repeat here. So the number of ways to rearrange them is just 4 factorial over 2 factorial 2 factorial. This ends up being 4 times 3 times 2 times 1, which is just 2 factorial, over 2 factorial 2 factorial. So 4 times 3 over 2 factorial is just 6. So there are 6 ways for May to go from her house to the library. Now, how many ways are there for May to do the next leg of this journey, to go from the library to her grandfather's house? Well, we could do the whole thing where there's 1 right and 2 downs, and that would give us, well, we're just rearranging these arrows, which would give us, if we have 3 different objects, and then 2 of them repeat, we would be doing 3 factorial divided by 2, which is equal to 3, right? Because that's just how the choose function works. So there's 3 different ways for May to go from the library to her grandfather's house, or we could probably just count them, since it's not a lot. It can be like this, 1, this, 2, or that, 3. But in any case, there's 3 different ways. And so for each way that May goes from her house to the library, there's 3 different ways to go from the library to her grandpa's house. So to find the number of total ways, we're basically just going to multiply all the possible ways to go from M to L and then from L to G. That's going to be 6 times 3, which is equal to 18 different routes May can take to go from her house to the library to her grandpa's house.